All right, welcome to GeoU University, GeoU. This is going to be class number 5, Field Procedures Part 3? Part 2? Part 3. Okay. Today what we're going to talk about is how to find pins using data collector. We're going to talk about to turn angles and distances. We're going to talk about how to find that angle between 2 points, between 3 points. And then we're going to try doing distance intersection to find a point. And then lastly, we're going to run through how to do rotate and translate. So this is our site. This is our prison site we're working with, and you'll see the highlighted numbers are the points that were found in the field. This is we ran the traverse around. At this point, we've run the traverse. We've found the pins, pulled the tape, used the metal locator. These are the ones that are found. We just cannot find anymore. So what we're going to do today is we're going to look at this pin right here, and we're going to make a stakeout point to find that pin. So what we need to do to start with is figure out the angles. Now this plat, it shows us a bearing. We're coming down through here north 60 degrees west, and we'll turn and go north 17 and change west. Turn again, go south 74 and change, and keep on going. So what we're looking for is, we know that this is 0.210. We know this is 886.
Both of those are found pins.
These are found pins. These are our shot numbers. So now what we want to do is we want to turn that angle from this line, turn it over, and then go that 157.24 feet to get this point. So best way to start is to draw a coordinate system based on your found point. That way it gets you oriented. On this plat, north is skewed a little bit, that's why this is skewed. So you'll see north, east, south, and west. Now this bearing right here is...
Show them the north arrow, John.
North arrow is there. So the whole site, the whole thing's twisted.
We're going to need to know north. We'll need to know north.
Yeah, you'll need to know generally which way north is. It just makes everything a lot easier.
Yeah.
Especially when you start getting into bearings in northwest, northeast, and so on. All right. So the green lines here show the lines we want, and that's the angle. The angle in between the green lines is the angle we're looking for. Now you'll see that this line is southwest, and this line is going northwest. That's because it's starting at this point and going in this northwest direction. Well, if you north 17 west just so happens to be south 17 east. It all works the same way.
And in what direction?
In what direction you're going, right. Same way with this one. This one is south 74 west. Well, if you extend that line out, you also get north 74 east.
John, I'll point out, unique to this plat, a lot of surveyors do it, is it has direction indicators telling you what direction it's going. If you look right there, see those lines? Those are telling you what direction the bearing is going.
Mm-hmm. Yeah, so it's probably on the original plat, there was a little arrow right here showing you, pointing that it was going northwest this way, northeast that way, and it just got lost after it got copied so many times. So this is what I was saying, the north 17 west is also south 17 east. So now we know that the way bearings work, that south 74 west, you start at the south line, then you go 74 degrees towards the west line to get south 74 west. On the southeast, you start at the south line and then go 17 degrees towards the east line to get south 17 east. And the angle we're looking for is going to be the angle in between these two green lines.
Does everybody understand that bearings are measured off of north and south, not east and west?
Yeah, let me stop here. Does anybody have any questions about anything I've said? I'm kind of running through this a little fast.
Yeah, slow down a little bit. I mean, you're hopping through it pretty quick. Let's talk the basic here. Everybody understand that we're measuring off the principal reading of north and south. For every bearing you read is measured either from the north or the south, depending on what quadrant we're in, right?
Mm-hmm.
The bottom two quadrants are measured off the south, top two quadrants are measured off the north. So I'm assuming everybody has got that, so that. All right.
Okay. So in this situation, the angle we want is going to be between the two green lines. So we're starting at south, and we go 74 degrees west to get this green line. We'll start at south and go 17 degrees east to get this line. Well, if you add up this angle and this angle, then that's going to be the angle you need in between the two green lines. The 17, 32, 11 plus the 74, 24, 42 makes 91, 56, 53. Which is going to be our turned angle. Now, one thing to pay attention to when you're doing this is that the data collector likes angle right. So if you're starting at 210, you're backsiding number 886, then the right is going to be going all the way around. Well, we don't want to add all those numbers up, so we'll go angle left instead. It'll be a negative angle.
Or you can do a quick 360 subtract.
Yeah, you could either subtract the angle we found by 360 degrees to get your angle right, or you could take a negative and go angle left. Any questions?
And real quick, just while we're sitting here, I just punched in my phone degrees, minutes, seconds to decimal degrees. The quickest and easiest way to do this is you have the degrees, minutes, seconds right here. Instead of trying to do a bunch of math to get that into a decimal form that you can add and subtract easily, man, I've got a converter right there. I just pull up on my phone and I can key this information in here, get the two different angles, add them together, and then you can just as easily take that same app and convert that back to the angle, or you can use, the data collector will recognize both, I believe, correct?
The calculator.
Which app is that? Because I've looked at it.
Not an app, that was just a website that had
Google does it.
Google degrees, minutes, seconds to decimal, and there's 2 or 3 of them calculators that came up.
All right, I'm about to go old school on y'all. All right. You don't have to convert decimals at all if you just realize what the whole that you're working with 60s. So you add up 11 plus 42, you got 53, right?
Mm-hmm.
If that happened to have been 53 right there, it would have been 11 plus 53 would have given me 64. Uh-oh, I went over a minute, so I've got 04 and I put a 1 over there above the 2. Now I've got 32 plus 24 plus another full minute, right? Which gave me the total minutes. If I went over 60 there, I got to throw a 1 over to the left. And then you don't even have to worry about the decimals. You're adding minutes and seconds, and you just do it. Just write it down and do it. It's not hard. It's just see, you got to think. It's just like a clock. Seconds. Minutes. Right? Anyway.
Okay. Now that we've found our angle, we'll go to the data collector. We'll go to COGO, compute point.
Let me, I'm sorry, I'm jumping one more time.
Yeah.
So everybody understands what we're doing here is the reason we need this angle right is what I call it. The reason we need it is because you can't use that bearing to create the coordinate. Why can't we use that bearing? We could, but we can't in this case. Why? Feedback.
Are we not on the right datum?
Correct. You're traversing on a datum that is not on the same datum as this drawing. Your north is different. You may be on state plane. You're not on the same datum this surveyor was on. But those internal angles, say he used a bearing to get his north, or a compass.
Yeah.
So, but that internal angle that you're calculating is correct. You're just applying that angle to your field data in your controller, right? Everybody grasp that? That's what we're doing right now. We're about to apply that angle and distance in our data that's in the controller and calculate new coordinates to stake out and put it in.
Okay. We're going to go 0.9000. We're going to make a new point using that turned angle. We're going to go to the drop-down menu, go turned angle and distance. Now the point we're going to start at is going to be this point up here, number 210. Our ending point will be our backside, if you will, down here, number 886. Our turned angle.
Why did you choose those two particular points?
Well, because we're looking for this pin right here.
Oh, that's the one we haven't found.
Yeah, that's the one we have not found. We found the highlighted ones,
Yeah.
but we have
That's
not
the
found
one.
this one.
Yeah.
So we're going to turn this angle to find, go that distance to find this missing pin. All right, our turned angle that we figured out a while ago, and this is where it's going to ask you for an angle right is what it defaults to. Now angle right would be starting here, backside in 886, and going to the right all the way around. You can do that, or you can go a negative angle, which is coming from this line, coming this direction over to this green line. So we're going to go a negative angle to keep things as simple as we can. And then our distance.
So those minutes and seconds you just.
Yes. Yeah, and data collector defaults to that. What you do is you put in
You got 50, you need 56.
56, like,
And yet another reason we're not full with converting to decimals.
yeah. So the data collector automatically defaults to minutes, degrees, seconds. So 91. And then when you put the point just is a placeholder to get you over to minutes and seconds. 56, 53. And then it shows you on the screen, 91, 56, 53. Our distance is going to be 157.24 feet. Okay, we'll enter, calc, and store that. Now, the most important step is this one, and that's to check your work. Don't just blindly run with this now because maybe you fat fingered a number, maybe the flat's a little bit off. So we'll check it. So we just calculated this point is 9,000, but we shot this one as 104, and that distance in between them is 300 feet
For the previous survey.
for the previous survey. So now we'll check it and see what happens. Good inverse. To number 104. 299.857. So we're 16 hundredths off, which is pretty good. You can find a pin with the 16 hundredths. So now you got a stakeout point. All right, so are there any questions, John?
Are you doing it this way just for training purposes, or you do the distance training?
We're going to get to this distance. Yeah.
Can I mention how to pull up the calculator? You go back to that screen.
Yeah. Which screen?
The compute point. You go down to hit the arrow next to turned angle. No. The turned angle field.
Yeah.
Calculator. And go down to azimuth. Alright, sorry, go back. You can just enter in the two angles and add them
Okay.
right there in the calculator.
And then the plus. No. How to use this?
I think you hit enter, or like reverse notation.
Oh, okay.
I think.
4.2442. We'll enter that number in. Yeah, and then we'll enter the next number, 17.3211. And then we'll hit the plus to add those, just plus,
Right.
or degrees, minutes, seconds plus,
That's it. You know what?
91, 56,
Yeah.
53.
Or you can also hit there's a button that says degrees, minutes, seconds if it confuses you. But that's
Okay,
what
we're
you're just
off the weeds, off the weeds. That's
Yeah,
good.
okay.
I like it.
So anyway, so you can hit that, hit the accept button, and it punches it in for you. So if you don't want to do it by hand, you can use a calculator to do that.
Do it by hand, do it by use your brain, that thing is amazing. So awesome.
Okay, so are there any other questions? All right, so now that's what you do if you don't have any data at all. Now, what do you do if you want a turned angle, but you have stakeouts already? The PM ahead of time keyed in this plat, made you a whole bunch of 9,000 numbers. They're just kind of sitting off at 8,000, 8,000. They don't match the survey at all. They don't match your points at all. So it's completely off by itself. Well, you can translate and rotate those, or if it's just 1 point, and all you need is just that 1 point, you can just do a turned angle to get the same thing.
Yeah, you calculate that turned angle on
Yeah.
the other data and
Correct.
use it to create a new point on your data.
Correct.
That's what you're saying, right?
Correct. So we know that 9,004 is what we're looking for. 9,005 is the same as 210. 9,006 is the same as 886. And we've already inversed 9,005, 9,006. We know they check pretty good. So now we're just going to turn that angle to find that pin. Okay. So the way you do that, you get back into the data collector, go to COGO, go to Compute Azimuth. And your method is going to be a bisected corner. The reason it's a corner is you have 1, 2, 3 points, so it's going to give you the angle between those 3 points. So side point 1, point 9,006, go here. The corner point is going to be the corner in the angle. I guess it helps put the right number in. 106. Our corner point, I labeled these wrong. Corner point is going to be 9,005 or 9105. And then side point 2, second side of our little triangle, is 9,004. Now, again, data collector defaults to angle right, so now it's giving us the angle right from those keyed in points. Now, this is not on datum, and we didn't have to put it on datum. This is just a simpler way just to find 1, maybe 2 points. You can find this angle.
So if you're missing just 1 or 2 pins,
Mm-hmm.
it's not worth it digging into a big old translate, rotate, moving a bunch of points here or there to just calculate 1 or 2 sets of coordinates. It's simpler to use angle right and distance.
Okay. Again, we'll go into compute point. We'll do this the same way. Turned angle and distance. We'll start at 210. And we'll end at 886. We'll put our angle right in this time since the data collector gave us angle right. And our horizontal distance is 157.24. Okay. And then again, most important thing is we check it. Go to COGO, go to inverse. It's punched in 9,001. Now we'll inverse. So we'll check it against this pin way over here, 104. 299.86. So it checks good. Okay. Any questions about how to find the angle when you have the points already?
That means y'all can do it? You need to, right? All right. Good.
Okay. So that's turned angle and distance. Now what we're going to get into is one of the simplest ways, definitely not the most accurate way, but one of the simplest ways to get a point that you can go look for a pin. It'll get you close, not always the most accurate way though. And that's going to be distance intersection. The way that works is what we're telling the data collector is that we know we have point 210 and we have point 104. And we know the distance to this other point. So the data collector is going to draw a circle from point 210, come out 157.24 feet, and it's going to come to 104 and draw a circle going out 300 feet. And let's run through how to do that. So go into the data collector, go to COGO, compute point, and this time we're going to change to distance intersection. Point number 1, we'll call that point 210. Then coming off at 210, we want to come 157.24 feet. Right? That's going to be our first leg, our first circle. Then our second one, second distance, is coming off of point 104. And our distance is 300 feet, according to the plat. Now this is the trick that messes up everybody right here. This statement right here, side of line 210 to 104. So if you understand what data collector is doing, it's just drawing a circle, a distance coming out. You got a green circle and a blue circle. Well, if you happen to draw a straight line between points number 210 and 104, 210 to 104, you'll see it goes through that circle actually intersects each other in two different places. So this point up here at the top is going to be the same distance away from the two found pins as the point at the bottom. So if we're drawing the line from 210 to 104, 210 to 104, then what we'll want is that point it calculates on the right side of that line. If you wanted this one up here, it'd be the left side, but this one's the right side. And to change that, you hit at the bottom on the button, Other. See, it puts it on the left side, and look what it does to those coordinates. It's changing them, several feet. More than that, a couple hundred feet in each one, every time you change between left side and right side. Right side is what we want, so we'll hit Store. Okay, so now we stored that point as 9002. Let's go to the map. And we'll go zoom in on point 9002. All right, so now see we've got all these calculated points and they are all just right on top of each other. Yeah. Now you see, oh, I hit the wrong button. Hold on. Okay, now you see how 9000, 9001 are right here? That's because the turned angle is going to be more accurate and take into account the differences in pins, because not every pin is going to be exactly where it's supposed to be, especially the older surveys. 9002 got it about 2/10 away, going off those distances, but that'd be plenty close enough to help you find the pin to wander around and then figure out if you need to set it or not. Any questions on distance?
Comment,
Yeah.
sir? So, never, minimize that screen there, go back to the plat for a minute. So never embark on doing a distance unless you have confirmed that your field data closely matches the plat between the two pins you have found. If that makes sense. So what I would do very first is I would inverse between 210 and 104, and I'd write that down. Then I'd inverse between, who's going to do that right quick? 210 and 104. All right, so it's telling me it's 429.3 feet. Then I'm going to inverse what the original surveyor said it was, which is going to be your 9,000 numbers. So 9105 and 9103. What's that inverse?
429.3. It's about 400ths longer.
All right, so that just gave me a tremendous amount of confidence in the position of the two pins I found. All right, that leads me to have a lot of confidence in the distance intersection. And likely, if you're on the phone in the middle of the woods, 2.5 hours from the office, and you call PM and say, "Hey, we can't find it. I did a distance off of that data right there." He's going to say, "Drive that in, put it in the ground, and we'll hold where you put it." All right? And you just saved us a trip if I lost to Georgia.
Basically, you made a decision whenever you did those first two by doing the angle. You're making a decision as to which one of those monuments you're going to come from to set a pin or to stake out the pin. So that's where that 2/10 error is coming in, is because that distance along one of those is 2/10 out roughly. So if you were to come from 104 and start calculating back to 9004 area, you would have shifted that over that 2/10. So we're talking about that much difference as to where you guys would have put that pin as to, either of these three ways that we just determined that. and you would have been fine. I guess the next question is, do y'all think that that is accurate enough to set that pin?
Y'all have directed it who?
All the field guys. Would you feel confident to drive that pin in the ground with using that procedure and the methods and what you just proved to yourself?
What distance does it? Or the angle?
Any of them.
The angle's
We were only 400 top, right? Isn't that what we said?
On that diagonal inverse, it was very accurate.
Why do you have the information accurate enough to be able to set it? Well, you've got a map here that's given to the nearest 100 and degrees, minutes, and seconds, because you've got an accurate map that you've proved closes with the monuments on the ground and the angles and distances that you piped in. You're doing exactly what we do. We just make a judgment call as to which one. And if I recall, there was concrete monuments out here on some of these. So that 2/10 is hitting somewhere on top of a 4-inch concrete monument. And you know that and the field before we know it. So if you go, okay, I got a 1/2-inch rebar back here at 210, and I got a concrete monument at 104, hold that 1/2-inch rebar and turn your angles and distances and put that sucker in, because you're still going to hit that concrete monument on that 2/10 off.
Don't want to hijack the two-part, John, but one more comment, sort of to Gene's effect there. Now, there's something called order of importance of elements, which is basically you learn that in legal principles related to land surveying, and distance is control over variance. That's in law. So the reason behind that is that we could, as surveyors, measure distances much more accurately early on than we could angles. Our angular measurement was dependent on a vernier scribed on 2 circles of metal. Okay, but we can measure a distance with a 100-foot steel tape pretty doggone tight, right? So it ended up becoming law that distance is control over bearings, and it still to this day prevails as the preferred method for establishing a corner. So out of all the methods so far, you're going to see that the distance intersection, if it's off of 2 good found monuments, is going to be the preferred method to put that pin in. You know, in the words of the late Trim Baker, though, we're not building a piano here. You get it within, he used to say, within, if I can throw my hat on top of what you all are talking about, it doesn't matter. Especially wherever this is, out in the woods, next to a cabin. It becomes academic. We become just a bunch of locksmiths sitting around discussing which tumbler is better than the other. They all do the same thing, mark a point.
Hey, John, go back to
Yes.
right, left of the line.
Do what?
It defaulted to,
Oh, the right, left.
yeah.
Okay.
So you went,
Get back to it. So it'll be distance. Talking about the left and the right side of the line.
right, and you
2
changed it.
There it is.
Is at the bottom.
Okay. We'll punch that in again. We'll get back to that screen.
Yeah.
What's that at?
The distance intersection is really helpful on older plats where they don't have bearings.
Yeah.
I've been able to find pins using that where didn't have any pins along the road. I paced up the distance from the intersection that it gave, and then used the distance intersection and got within 10 feet of a pin.
Okay, we're back on the screen where it says right side, left side.
So that's determined by what number you put in first.
Yes. Mm-hmm.
Okay.
But it shows you on the screen what it's doing.
What it's doing.
Yeah. So draw a straight line between 210 and 104.
And by
like
looking
that.
at that, we know it's to the right.
Yeah.
If you're standing on 210 looking at 104.
Right. Okay.
You need to make those centered on the points and not stretching between the points. Might make more sense.
Feel like you were, yeah, there you go. Yeah, we pick your point. We draw a circle, whatever the distance is along that property line. We put it on that pin. We draw a circle, just like that right there. So those circles would be centered on your pin, and then you can see where they would intersect.
Mm-hmm. So yeah, you see where it intersects down here. It also intersects up top up here. So if you draw a straight line from 210 to 14, you want the right side intersection.
And if you draw that out on that map, you know exactly which way to do it.
Yeah, so take your hand out.
Oh, just sketch it. And then-
Yeah, sketch it.
Physically draw that line.
Okay, that's a good question. And then to change it, it's just other at the bottom.
Okay.
It's left side to right side. Okay. Any other questions? No? Okay. All right. So that's distance. Now we're going to run through translate and rotate. Okay. So we've got a printout already. We've got all these 9,000 numbers already given to us. So let's just pick 2 points. Points we're going to pick, we're going to go with 103 and 845. So we'll inverse those two and see how they check.
Oh, you're doing that right. I'm sorry, I thought you were about to jump into it and not describe inverse in between them.
Yeah, we're going to inverse between them and check them. So
Okay. I'll shut up. Sorry.
we're going to do 103 to 845. We'll go with inverse. $1,058.76. And that's going to be from the pins that we actually shot. Now our points that we had given to us are 9101 to 9108. $1,058.3. So we're 4/10 difference across the entire 10-acre site. That's pretty good for finding pins. So we'll hold that. We'll go with that for now. So what we're going to do is we want to take all these 9,000 numbers. Right now they're just floating off in space, totally different datum. If you look on the map here, here's our site. We're up here on state plane coordinates. Here's our 9,000 numbers. They're down here on 8,000, 8,000, just an assumed datum, just to have us something to start with. So we're going to take all our 9,000 numbers and we're going to drop them on 103.
Right here, let's discuss this if you don't know.
Mm-hmm.
What's our preference? Move our field data to the plat or move our plat to our field data?
Plat to the field data. If you move the field data, it erases all of the turned angles and distances from the raw file.
We don't really do that.
Yeah, we don't want to do that.
So everybody got that?
Mm-hmm. So you leave your traverse, leave your points alone. You
Don't
take
mess with your
the
field
keyed in plat and move it and rotate it as needed.
Yeah.
Okay, so we'll go to transformations. Go to Kogo, transformations. And then what we want to do is we want to translate right now. We just want to take that block of points and move them. So our method is 2 points. Our from is going to be our keyed in points down there in the middle of nowhere. And look right here, number 9101 is the same as 103. So we'll go from 9101 and move that on up to 103. You can see it's moving it about 1,000,000 miles north and east.
To be clear, if you had from 103 to 9101, that's going to move the point you shot, which you don't want.
Right, yeah. The from point is where it's coming from, the 2 points where it's going to. So you want to take your plat and take it from the assumed datum to your datum.
Transform means move.
Yeah.
That's what it means.
Okay. Click next. Now it brings up a list of your points. And you can filter these points by hitting the filter. You can turn off your topo points. You can turn off your stake points, but you want to keep on your keyed in points. It'll bring up the list of all the points you've punched in, which in this example is all of them because I punched all these points in. So you'll have to select each one you want to move. 9101. And just keep Tap on all of them to select them all. There we go, that's all of them. We'll hit accept. Transform 9 points.
Didn't select that.
9108.
It's 9108, but that's fine.
Okay, well, we'll remember that. So, okay. So now, what we've done is we've translated that block of points up to 103.
Question, John. Is there a way to undo last translation?
Does anybody know of a way? Not to my knowledge.
Okay.
Did you say you missed 9108?
I missed one.
You need 9108.
That's the one you go with.
No,
So
yeah.
then just translate it by itself now.
Okay.
Show them, well, you can't do that because you don't have that coordinate.
Yeah. Okay. What's supposed to happen? Okay, so here's what we'll do. We're going to.
Close it, not save it, redo it, right?
No, you can't do that. Not in data collector. Okay, so let's do this.
Key it in.
We'll key it in. So we're going to take 91. What was the one we were translating to?
9108.
9108. Now we have 9108. It's just down here all by itself. So here's our site up in here. All our points right there. Well, there's 9108 all by itself. Well, we don't have anything to grab it, move it to, so we're going to have a second. We're going to put in a second point. We're going to re-enter 9103 down here, or 9101. This one down here. Let's re-enter that.
And the reason you can enter just one is because he hasn't done a rotation.
I have not done a
It's just
rotation yet.
A plain translation. So
Or
you
you
can use that one point to get that same translation.
So you move it first, rotate it second?
Correct.
All right.
All right, we're going to rekey in the point 9101. We'll call it 9102. This is just so we can have a starting point to move this other one that I messed up. Okay, so what I did is now we have 9108 down here on assumed. We also have 9201 down here on assumed. So what I can do is I can take 9108 and 9101, move those, or 9201, move those to 9101. I'll take that same group of points and move it up to where I just moved the other one. This is not what we have to do every time. We're doing this because I screwed it up. Go to GeoU, transformations, we'll translate. Okay, we're going to go from when I just keyed in 9201. We're going to move that on top of 9101. And this time we're going to move 9201. We'll go up here and grab 9108 that I missed. All right, what that did, it just moved 9108 back up to where it's supposed to. And what we can do is we can check that. 9107 we moved first, 9108 we moved second. So let's check that and make sure that worked out right. Okay. North, 30 degrees east, okay, 269.81. 7009, okay. Did
You could also compute the point
You can also compute
from
the point.
9107.
Yeah, so anyways, we got the points in there now. Now we have all our 9100 numbers where they're supposed to be. Now let's double check that 103 and 9101 are still the same point. So go inverse. Okay, 0. So that's moved right on top of each other. Now, we haven't rotated yet, so now let's see what the difference is between 9108 and 845, since that rotation is going to be off. It's 100 feet off because of the difference in rotations. Let's go to the map. Let's go zoom in on that and we'll take a look at that. Okay, so there's 845 up here. Well, there's 9108. It's way off, away from where it should be. Here's 858, here's 9107. The whole thing needs to be rotated. Okay? So here's what we're looking at right now. 9101 and 103 are the same point, but 9108's way down here from where it should be, and 845's up here. So now what we need to know is we need to know what this angle is that we have to rotate to. So we'll go back to our data collector. And we'll calculate that angle. Go to COGO, compute azimuth, and we'll go to bisected corner. Now side point 1, this is going to be our line right here, side point 1, 9108. Our corner point is 103 down here. We already moved it. Inside point 2, so this is 1, here's our corner, here's 2 up here, 845. 5 degrees, 33 minutes, and 8 seconds. And then that'll be the angle we're going to rotate. Okay, so you want to escape out of there, go to COGO, transformations, this time we'll rotate. Our origin point is going to be the point we want to stay still, where everything else rotates around. And that's going to be number 103 down here. And then we'll punch in our rotation angle that we just found out.
John, right
Yes.
there, before you punch that in, if you push that right arrow, is there a chance for a bearing right there?
No. Trimble software does not give you the option to.
Stupid program right there.
Yeah, it is. But that's the way you have to do it. Is you have to punch in the actual angle. It's going to be 5, 3.
This is why it's so hard now for us to do this as compared to the old Rangers.
Oh, yeah.
The TDS, you just put the 3 numbers.
Mm-hmm. Okay. Now we have to go through and select the points. This time we're going to select all the points. 9101, 2, 3, 4, 5, 6,
It's 9103.
9. Okay, good then?
9201.
201, but we don't need to move that one. That was just something I made just to get by. Okay, looks like all of them, so we'll go to accept.
So you
10
see how
points.
important it is to get all those numbers. You don't want to leave one hanging.
Yeah, and you don't have the option to do a range, point range either. You have to actually select each one you want. Okay, so now we've rotated our points. Now we're going to check our rotation. Go to COGO, go to inverse, and we're going to inverse between 9108 and 845. We'll see if that rotated properly. And 4/10. That's our rotation. We've rotated in. Now we're locked onto the site within 4/10. We can go around and we can look for pins as needed.
Okay, so conversation here. When would be appropriate to choose doing this translate rotate function versus what we discussed previously? Because you need to know, you need to understand when should I do one versus the other? Okay, I'll answer.
Translate rotate you want to do when you haven't found any pins at all.
Well, you have something.
Well, no,
Well,
you're gonna have to find something.
You have to find at least one, or yeah, you have to find some, but
Well, you want to compute points if the project manager didn't give you any stakeout.
Okay, here's the first governing factor. It's easier to enter a bearing at a distance to calculate a coordinate than anything. That's the easiest thing there is to calculate coordinates, is a bearing and a distance. Or somebody gives them to you.
But
Those are the two easiest ways to get coordinates. If someone is giving them to you, and you're needing to look for multiple pins, it might be easier to translate and rotate and throw all that down on your data than sit there and calculate all the angle rights and distances and do that traverse on your data, right? If all you need is one, I wouldn't go through all that to get that. I'd just sit there and calculate my angle right distance, turn it off my 2-pound pins or whatever, and pop it. And you didn't go through. That's why we gave you these tools. So you've gotten yourself 3 sets of tools here that you can use, depending on complexity and certain scenarios. Yeah? Okay.
Are there any other questions? Okay.
Why did you choose point 103 to rotate from and then 845 to rotate to?
I just chose 2 points far across the site. I really could have chosen any points. I mean, if you choose numbers 210 and 886, well, that's a very, very short point. And you're going to have error in every shot, in every pin you find is going to be a little bit off from what the previous surveyor said it's going to be. So if it's off a couple of hundredths, by the time you translate and rotate to just that angle, this one over here could be several feet off. Whereas
Here's a great way of understanding that concept. You can't take a 2x4 and pick it up by the 2 ends of that 2x4 and hold it up because it's too short, right? It's too heavy. Same thing in mathematics. You try to orient that whole site to a little 100-foot distance, it's too heavy out on the ends, and it's going to flop around and be everywhere. But if you grab it by both ends, everything else in between is pretty solid, right? So the longest you can grab. So the very first thing we do is sit there with, at the end of the day in the hotel room, you're trying to do this. You're going to just sit there and do some inversing on plat and on your field data. I do a bunch of different inverses and find that longest diagonal that's got a rough check. Decide, all right, there's what I'm going to use. Boom, grab it and move it to it.
In this particular instance, what would be the best points to hold to translate and rotate?
9107, 9109.
You found the pin at 91.
Correct. And that's actually where we found 2 pins. Because the only pin missing, I believe, on this one
It's 9109.
was that front. Well, 9100 was missing right there, and then that one down the line there. There was one of those 2 I think was missing.
9109 is missing too.
Yeah, we had 2 pins that were missing out there.
okay.
9109 was missing on the
Yeah,
front right?
I set that.
Okay, yeah, you set that one. I forgot to get you to set the front left. That's what it was.
Okay.
So, okay, so we got a real-time example. Tim, I don't want to make an example out of it, but I am, because we had an opportunity last week. Residential West Cobb pasture, one missing pin back corner. That found pins, and it's been pretty easy now that you've got these tools we've just given you. You could have taken that flat, turned that angle, gone over and calculated those coordinates, and likely with a phone call, you could have said to the PM, hey, here's what I got. Create those coordinates, I inverse back out to the road, and I'm off 2/10 on the one out of the road. You know, what's Craig going to say? Drive that pin if you don't find it. And now, so we just saved entire site mobilization, moving equipment out there, getting set up, just set one pin. We got to set the pin, state board rules. We got to put it in. We can't ignore not putting it in. So that's a prime example of an easy opportunity we could apply the calculate those angles and dropping those pins in without having to orient it to it or anything.
All right, you ready?
That's it. So Gene now is gonna go over coding. I know we've already covered it some in an earlier class, but this is leading up to Gene doing our next class. So we decided to use some time at the end of this class for this.
Take one and pass on around. I don't have anything for you guys to look at really on the screen here, so let's pass out our code list, which y'all have all seen laying around hopefully back here, and you use it, it's in the data collector, it pops up. But just wanted to briefly discuss the code list, what it is, how we use it, and very general specifics about it. Basically, we use Carlson Field to Finish is the software that we use to process what you guys do in the field. What that does is that starts with using your points sequentially and then goes into reading that code that you guys use and whatever numerator or number that you guys put at the end of that code. It uses that as a sequencing thing to connect those lines. And whether you guys actually know this or not, most all of our codes do some form of line work unless it is an actual singular structure, like a light pole or a fire hydrant. Those type items, they get a symbol, not line work. Signs, for instance, if you guys shoot signs, that will draw a line work. So if you put a number on it or you don't put a number on it, it will draw line work regardless. If you use SN and no number, every SN that you shoot on that site is going to get a line connected to it. That is set up purposely in our field of finish to allow us to see every place you shoot a sign on your site. We make the decision to show signs or not show signs. You're going to be told by your PM as to whether or not you shoot something like that. Are there any questions that you guys have about any of our codes that we use as to how they apply or don't apply?
Concrete corner. There's that one.
Concrete corner is kind of an older code. Way back in the day, we shot a lot of pads in CC1, CC2. We may shoot 3 sides of something, and we wanted somebody to know that it's not just an EC. We wanted to know that it's the actual corner of a piece of concrete. So you might have EC1, CC1, and that's when we were mainly drawing things by hand. But with field to finish, there's no use really for a CC code. It would be edge of concrete 1 at the corner and just shooting it at the points that it needs to be shot. Does everybody understand how we run curves? Yeah, Rob?
Well, first off, don't we use TAD for what you're talking about now, the, I guess, elevated concrete pad?
There's no specific right or wrong way with that. A pad it can be a multitude of different types of surfaces. It could be an asphalt pad, it could be a deck, it could be concrete. That pad is just there to indicate, usually a pad you would shoot 2 corners. You would 90 it into a building or something like that. That would indicate that there's a pad coming off of something to alleviate you having to shoot those 2 extra shots up along the building.
Yeah.
Everybody understands how the line work connects?
Did you say a sign? If you just say SN, it will draw a line?
SN is always going to draw lines for our field to finish. If you put SN1 and you shoot a big monument sign for a Kroger, and you shoot SN1, and you shoot that next corner, and then we always alleviate, the 4th corner because we know it's going to be a rectangle. 4, enter, bam, it makes it square in our AutoCAD. So there's no use for you taking that extra shot.
Yeah.
If you shoot just SN, like one of your stop signs,
Yeah.
SN dash, and then y'all put the descriptor on there, stop.
Yeah.
Well, what it'll do is the next SN stop or any SN, whatever the next one is in your sequence of points, say stop sign was shot at number 100. Well, let's say you go and you shoot the next SN with no number on it as a yield sign at shot number 240. It's going to draw a line between those 2 points.
Well, that's not necessarily wrong.
No, it's not. That's
It helps
not for
us
you
keep up with
guys.
the points so we don't lose it and we know.
Exactly. That helps us see, okay, shot a sign, so we don't, accidentally turn that point off and not draw the sign. Because obviously when we're shooting these state DOT routes, it's required that we locate the signs, and that's why, for the most part, we're shooting those all the time now, because you're almost always on a state route. If you're on a a little residential site or something like that, and you're shooting residential property or up in a commercial development, you may not need all those private signs. I would tell crews sometimes, you don't need the little private yield signs and stop signs and stuff. What you need are the signs that are going to be, I know we're getting into weeds on signs, you need the signs that are indicating what a building number is or something like that, a more substantial sign. Or a Chick-fil-A sign for an entrance or an exit coming in and out of the property, because that sign may be off and encroaching onto the neighbor's property. Dashes and spaces. Does everybody know how we use our dashes and spaces? All right, Rob, what's a dash do?
Dash is or if you want to identify what you're talking about, like or descriptor.
What would you add a descriptor to?
So if you're doing a gutter line, you want to do, because you know how thick the gutter line is. So the gutter line, you want to dash 24-inch curved gutter, and that lets the project manager know what type of gutter line to put in there.
All right, and when would you use a space?
Double codes, if you want to do point of tangent, point of curve, that'd be just a space.
Well, double coding, obviously, and then shooting your curves. We typically shoot 3 points on a curve. The PC, and then the point on the curve, which we don't actually call POC anymore. Carlson understands that once you begin a curve, that until you hit PT, it won't end it, and it'll do a best fit through those curves. So typically we're doing PC to PT, but correct me if I'm wrong, I believe you can just go PC to PT and not shoot the POC, and it will draw the curve. If it's a good radius, consistent, and it goes, and you're shooting an island,
It's tangent.
and it's tangent. So if we're shooting a bunch of islands out in a parking lot, and that's not a good example, but
Is that
that
potato?
point,
That's a potato.
we don't necessarily have to have that right there. You can go and you can draw that thing around, and tangent's going to run back down PC and PT. On this code right here, say you start it here, your gutter line 1 space PC, gutter line 1 space PT, gutter line 1 space PC, gutter line 1 space PT, space CLO. What does that do?
Closes it.
It draws that right there. Connects that back to there. We get a 3D barrier line, and we get the 2D line that we use to offset. So it gives us 2 different lines in our field to finish.
You did that with 4 shots.
You did that with 4 shots. Now that's assuming that your low points aren't right here running through your parking lot, and that this right here is a low area, and you've got all these curves, and they've got drop inlets or something like this. You don't want to be shooting this right here and miss these low areas, when all you'd have to do is pick them up with a curve shot right there.
You may need it for a Z.
Exactly. But for horizontal as-builts, you don't have to shoot all those extra curve shots. NE codes. What gets an NE code?
Reflectorless shots, and you're not doing building height.
And when you're using these NE codes, like if you're going to shoot a building height, obviously building height has got a code for itself. You don't have to use NE on a building height. We have a building height code. Was it BHGT?
Mm-hmm.
That right there, code alone, tells us, and we put finish 4, the finish 4 later. We freeze that before we're going to run topo or anything with vertical. It cuts off fire hydrants, because in the past we've always shot fire hydrants up on the top. We've had a previous meeting where we discussed fire hydrants. It doesn't matter. We don't shoot them on the top. We don't use those as benchmarks like we used to. We use our actual control points in the ground. That's what we give people for stakeout, layout, and benchmarks. We're not going to give them a fire hydrant unless absolutely have to. We want to give them something a little more accurate and that we know was shot very consistently. So, finish floor, building heights, top steps. When y'all shoot something that's a top step, that goes on a layer in our field to finish. That is, it goes to our finished floor layer within the CAD file, and we freeze that layer so top steps disappear. We use those specifically for drafting, not for elevation. Ramps, a lot of people are shooting D ramp, T ramp, bottom ramp.
Gene, that's not always the case.
What's that?
If the top step's a concrete step on the ground, it will be relevant.
Well, it goes on a layer that's finished floor. So if you freeze your finished floor layer in AutoCAD, it'll go on that layer. Now they're supposed to be shooting those on the ground anyway and not walking up to the top of a pair of steps. Y'all remember that, right?
I'm just saying ones that are like going up a ground, up a slope.
Yeah, but you would have to specifically do that in-house to make that work for you.
Alright, so
Yeah.
they do get turned off.
If you cut off finished floor, the top steps cut off, I believe. Just because we've got it set up that way. We can tweak our field to finish. You guys have to let us know, hey, there are 30 steps out here on this site that I shot. It's a commercial development. And there are those concrete steps, and they're at the dirt, and they connect, whatever parking lots from one side of the parking lot up to the next. Those bottom steps and those top steps might handle everything we need for drawing the barriers and actually drawing the steps. But we would need direction from you to know, hey, I shot the top step, it's at the dirt and on the concrete. We could use those. Versus having to run more ECs. 35 codes. The infamous Jamie basketball number code. Alright. We were trying to decide what to call shots that we didn't have a code for in our hundreds and hundreds of field codes that we've got, that we don't use a lot of them anyway. Obviously you can tell utilities is the one that's got the most. And Jamie decided that he liked 35 dash because that was his high school basketball number.
And Herschel Walker.
Yeah, and Herschel Walker's football number.
He's 34. He's 34.
So I vote today that we nix 35 from here forward. I'm just kidding. When at all possible, you always want to make an attempt to not use 35 codes. We have too many codes. And you have the capability of just being consistent with how you code things on a site. If you run across something that you need to shoot a whole bunch of them, go ahead and identify what that item is, take a photo of it, send it to us, call it something and be consistent. If it's a single shot item, shoot it, call it, be consistent, write it down in your field notes. We can take care of that in the office. It doesn't have to be, it's not a dead fast rule that it has to be on this list. If you're shooting anything that is on the surface of pavement, and you're on a pavement surface, and you get something that's in the pavement, and you want to identify it, you're going to shoot it on the ground, and we can use it for topo. PS dash what you think that thing is, and maybe say CPIC. You can throw descriptors on the ends of those single ground shot, concrete shot, pavement shot. Those shots are always on the ground and they can be used to identify things that are on the ground. You just need a descriptor at the end of them for you guys. Sometimes I see C photo. And I'll go and I'll look through the photos and go, okay, let me see if I can find where this is, and maybe there'll be a little bit more direction or something like that over in the field notes. Water vaults, some of the things that we shoot that we've told you guys to try to keep stuff on the dirt. And I know we've had some confusion as to shooting sidewalks versus water vaults and where to shoot those. Well, if a water vault is sticking up out of the ground a foot or two and it's a big box fault structure, which is this hollow, it's got a metal lid on it, and they may not have set that thing flush with the surface of the ground so that you can shoot it and the dirt and the concrete are the same. Well, we could care less about that little 10 by 8 box sticking up out of the ground. We're not going to topo that. We want the dirt. So you would shoot a water vault on the ground, but you'd call it water vault 1, water vault 1, water vault 1. That draws 3 sides of it. We square it off, we're done. No need to hop up on top of it and get any other shots. That's a waste of shots. Unless you specifically are told, get me something up on top of it, don't worry about that stuff. We don't get inverts on them, so we don't need it. And contrary to that, if you're shooting a sidewalk, we spot elevation those items with 2 decimal places. So always shoot, if you call it EC, shoot it on the concrete. And it's to be accurate within 100, because that's how we label it. Don't drop down and shoot the dirt unless your sidewalk sticks like this up out of the ground, then we need a ground shot. That'll indicate we still need the EC, and then you'll drop down occasionally and get us a ground shot. You don't necessarily have to shoot it as often as you do the EC. Possibly the EC is doing all kinds of curves and so forth. Anything you guys have questions on or see on here or run into that?
You have PBX on here?
Yes.
I've always been using EBX.
They both work. You guys,
What is it?
Nathan said we have PBX on here and we don't have EBX. I've got a bunch of codes in the field to finish that are old codes / ones that we went to here. This right here are the ones that we want you guys to try to adhere to. So if we hire somebody tomorrow, we're going to give them this list. They're not going to know about EBX. But EBX is something that I'm not going to make stop working, because in your mind, when you come across it, I don't want to have to correct that. So what I do is Carlson can be set up to have companion codes and so forth. So if you call something PBX, I'll make EBX work for it also, and it'll bring in the same little symbol for it. We also have PowerPed. Nobody ever shoots PowerPeds. We've had the discussion as to, we have TPED or CPED. TPED's the old code, telephone pedestal. We quit getting that specific on our utilities and just went to CPED for communication instead of trying to identify it as something other than telephone or cable TV. Power pedestal, in my mind, would be something that sticks up out of the ground. It's a power box. Maybe it's a power outlet or something like that. You might throw that on the descriptor. Just let us know as specifically as you can with a dash what it is without getting too wordy, because every time you've got to push that key, you're wasting more and more time trying to do that. So we try to give you something that's as abbreviated as possible, but if you find that one of these codes is just too long and we maybe have a better way to shorten it to make things quicker for you guys in the field, let us know. We can edit this stuff very easily. But it just can't contradict with something else that we've already got in the code line.
Out 15? Getting close. What you got? We'll go one more and then everybody out of here.
I was going to ask, on Alta, when it comes to shooting a weir, do you just need one shot on the top, or do we need all the sides?
On weirs,
Yeah.
we've had them shot 100 different ways over the years. Typically, we want, if the weir is level and it's flat on the top of that weir, you're going to shoot the top center of it, and that's going to be from wherever you're measuring the inverts from. That's the weir.
Alta survey.
Oh, on an
We're
Alta
just looking to
survey?
get,
Yeah,
just a
location
single
of it.
shot.
Yeah, a single shot on that thing, we're going to draw it. And just maybe tell us what it is, 4 by
Maybe a
4.
4x4 weird.
Yeah. One shot, preferably on the top of it, but don't waste time climbing up on top of a weir if you lean the rod over there and get it and just maybe put -NE on it so we know that the elevation can't be used.
Okay, I feel better about my last time.
Yeah.
It really depends on what you're going to use the weir
That's
for.
right.
I mean, what the weir.
If it's being used for topo, then you need that shot from wherever you're going to measure those inverts and a couple ground shots around that thing possibly, because a lot of times they're sitting in the slope.
Yeah.
So if it's sitting on the slope, you might need a ground shot.
How would we, Tom's talking about oval pipe factor, making it complicated. That's a special subcircumstance. That's what field notes.
Yeah. Well, obviously, and this is something that I didn't bring up. When we shoot pipes, it's not the size first. It's always the type of pipe first. You guys remember that. If it's a corrugated metal pipe, if it's a reinforced concrete pipe, if it's a what's the one we call CPPs? Anything that's plastic, a lot of them we call them CPPs, but they're not CPPs. They're HDPE. That's a smooth surface. Outside is corrugated. If you get one that's in South Georgia, for instance, when we get down there and they get a lot of them because they don't have the cover and they'll squash those things down and make them really wide, then it's usually RCP. You shoot